Here we show faults. And if this fault, for instance, is sealing, it will mean the fluid on its left can't flow to the fluid or to the region on its right. And so they can have different pore pressures. And that's what sealing faults, sealing fractures do. And because they prevent flow, like I said, then the pore pressures can be higher on either side. And that's how you can create compartments in space. But with depth, like I explained on the previous slides, sealing layers can prevent hydraulic communication between the sands above or below the seal. So these two phenomena can work in combination such that you can have 3D compartments. So you're sealing them off from the left and the right by fractures, and you're sealing them off above and below by sealing layers. And the main idea is that those seals are impermeable. If they were permeable, meaning they were conductive faults or conductive layers, what is going to happen is what? The fluid at higher pressure will flow from the compartment of higher pressure to the compartment of lower pressure until the pressures equilibrate and they wouldn't be compartments anymore. And we show an example of those right here. So this is a field in Louisiana. You see the 4 blocks as the black line. The dots are the wells, A through E, and the colors of these dots here are used in the color of the plot of pore pressure, bottom hole pressure versus time. And let's speak, well, I should also mention that the fault blocks are illustrated here, right? Fault block 1 is here, fault block 3 is here, fault block 2 is here, and they are bounded by faults, some of which will be sealing. And how do we figure out whether it's sealing or not? We use the pore pressure. So we look at the color codes for well B and C. Wells B and C. B is green. So this is wells B and C. They are separated by a fault. And the question is that fault sealing or conductive? So this is the green, this is the red. They all follow similar trends, right? So that will indicate that they are actually in communication. They are in hydraulic communication. So this fault right here is not sealing, definitely within this region. If it were sealing, they will have different pore pressures. How about, well, A and C? So A is here, C is here. Is this fault sealing? Well, this is the profile for well A, right? Right here, the blue. First off, it comes out higher, even though you start out production at a later time, right? This is the time interval. And it's always higher than that of wells, than the pressures of wells B and C. So it's a different compartment. If it weren't a different compartment, meaning if this fault was conductive, then the pressure in this region will deplete as the pressure in this region depletes. So this fault is definitely sealing and preventing hydraulic communication between wells A and C. And that same concept can be applied to explain the other trends you notice. The other interesting point is this. After about 15 years, you can check that out from the axis. After about 15 years of production, you would expect the pore pressure in this fault block 2, which is right here, for wells E and F, to start out from these low pressures, which is the pressure in all the other wells that have been depleted, if this fault was conductive. But the fact that you are still able to produce at very high pressures tells you that this fault is sealing, and it prevents the hydraulic communication between these depleted areas and this newly produced area, which is being produced by wells, ENF.